It's time to learn about linear, quadratic, and exponential models. You've actually learned about all of them, but it's time to put them all together and notice all the differences between them. Woo! This is going to be so much fun! The first function we're going to look at is the linear function. You spent a lot of time studying the linear function early in the year, and if you remember, I would like to call it linear because all of your graphs of a linear function are straight lines. And then you also have the formula y equals mx plus b, where m represents your slope and b represents your y-intercept. So, starting out, if we just have y equals negative 2x, and we want to graph that line, you can either graph it using the y-intercept and the slope, or, when in doubt, you can always make an xy table. So if we were to make an xy table, you could plug in negative 2, 0, and 2. If you plug in negative 2 times negative 2 is a positive 4, 0 times negative 2 is 0, and then 2 times negative 2 is negative 4. So if you graph negative 2 up 4, 0, 0, or over 2 down 4. Which you could have also done this using the slope and the y-intercept, knowing that the y-intercept is 0, and then the slope is negative 2, down 2 over 1, down 2 over 1, or up 2, left 1. Just realize that this point's in the wrong spot, so it should be right here. And then you can just connect your dots to make this straight line. When given a table of values, you will have to be able to recognize the patterns within the table, and then be able to determine if that pattern is linear, quadratic, or exponential. So for the first case, here's a linear function represented in a table. So if you look at the bottom, it says the first difference is the same. What that means is you're going to look at how the values change on your y, and actually on your x. On your x, they go up by 1 each time, and on the y values, they're going down by 2. Down by 2, and down by 2. So if you notice, that right there is the first difference. When you subtract the difference of your y values, you should get the same number every time, and that right there tells you that that is a linear function. Now, we're going to write the equation for this table of values. We already decided it was linear because the first difference was the same. So we're going to write an equation in the form y equals mx plus b. So first we have to find the slope, which remember is m. The slope is always the change in your y values divided by the change in our x values. So if you remember, our y values went down by 2, our x values went up by 1, so our slope, negative 2 divided by 1, is negative 2. And then we want to find our y-intercept, which is b, and if you remember, early in the year, you always look on the x side of the table and find 0. And then what y value matches up with 0? Negative 4. So our y-intercept is negative 4. And then to write our final equation, y equals negative 2x minus 4. So for the linear function, the graph is always a straight line. A table of values, the first difference is always the same. And then to write your equation, y equals mx plus b, where your slope is the change in y divided by the change in x. And then the y-intercept is always the number that matches up with 0. This whole unit we have been working with quadratic equations. Today we're going to work with just the one form where it's y equals ax squared. so just the monomial version. To quickly graph, here we just have y equals x squared. We can once again, you can always make an xy table to graph any function. So in this case, let's plug in 0, 1, and 2. And you should remember it's a quadratic, so it's going to be a parabola that is symmetric, so we're going to graph points on half of it and then reflect over. So if you plug in 0, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So if you plug them in, 0, 0, 1, 1, over 2, up 4, and then we can reflect those 2 points, and here we have our parabola. Now, by looking at a table of values, you also have to be able to determine if you have a quadratic function. If you look down here, this time it says the second difference is the same. For the linear function, it was the first difference is the same. So this is what it means by second difference. You have to first find the first difference. So how are all of these numbers changing? 9 halves is really 4.5. And then 4.5 minus 2, it's going down by 2.5. And then from 2 to 1/2, it's going down by 1.5. And then from 1/2 to 0, it's going down by 0.5. So that's the first difference. When the first difference is the same, it's linear. Second difference now basically means the difference of the difference. So now let's look at from negative 2.5 to negative 1.5, it's actually going up by 1. And negative 1.5 to negative 0.5, it is going up by 1. So because the difference of the difference, or the second difference, because you get the same number, that means it's a quadratic function. Now we want to write the equation, the quadratic equation that corresponds to this table of values. So our goal is to write it in this form, y equals ax squared. So really we just have to find the value of a. And to do that, you can pick any point on the table except 0. But if you pick any other one, let's say we pick negative 2 and 2, which has an x value and a y value, you can plug in x and y into this equation and then solve for a. So y equals ax squared. Let's plug in our values. Y is 2 equals a, and then x is negative 2, and that's squared. So negative 2 squared is 4, so 2 equals 4a. And now to solve for a, you have to divide both sides by 4. And 2 divided by 4 is 1/2, so a equals 0.5 or 1/2. So now once you find a, you now rewrite your equation. Y equals a is 0.5 x squared. And now you have the quadratic equation that corresponds to the table of values. And the last function of the day is the exponential function. And if you remember, the equation is y equals a times b to the power of x, where you usually have numbers for a and for b, and then your variable is your exponent. So let's quickly graph y equals 4 to the power of x, and once again make an xy table. Let's do negative 1, 0, and 1. When you plug in negative 1, you should get 1/4 or 0.25. When you plug in 0, anything to the power of 0 is 1, and then 4 to the first power is 4. So if we graph these, we have got negative 1 about 0.25, 0, 1, and then 1, 4. And if you remember, our exponential functions have an asymptote where they're really close to the x-axis but never crosses. It kind of curves and increases very quickly. So there's your graph of an exponential function. And finally, we have to be able to look at a table of values and know when it represents an exponential function. For the last two, linear and quadratic, we had to think about addition and subtraction on the y values to see how our numbers change. But exponential, we have to think, how do our values increase or decrease by, multiplication or division? So instead of the difference or the second difference is the same, like the growth factor or decay factor is the same. And one thing that you can always do is just divide up the table. So what is negative 128 divided by negative 32? Well, you should get 4, so that means you're multiplying by 4 to go up the table. Negative 32 divided by 8 is 4. So we're kind of going backwards, but then when you go down the table, it means that you're multiplying them all by 4. So that is your growth factor. Now we want to write an equation for this table of values, which means we need to find the value of A and the value of B to write our equation. So the first thing, A, is always what I call the initial amount. In other words, it's where do you start, or what number matches up when x is 0. In this case, it's negative 2, so A equals negative 2. And then B is the growth of the decay factor, and that's simply just the number that you're multiplying by when you go down the table, and that's 4. So B equals 4. So then our equation is y equals, if A is, negative 2, and then times 4 to the power of x. And there is our equation. Whew, that was a lot of information. I am exhausted. Time for bed, but don't be afraid to wake me up if you have any questions. Good luck with the lesson.